Hello and welcome to another video. Today we're going to be solving 3 problems that appeared on the January 2026 Algebra 2 exam. So here we'll first start off with this question right up here. It is a multiple choice question, and the question says, the value of t in the equation 27 to the 6 minus 2t power is equal to 9 to the t minus 1 power. So we'll see here that we have 27 raised to a power and 9 raised to a power. And what I'm immediately thinking is that these are both numbers that are based on 3. So, for example, what I mean is that 27 is 3 to the third power, and 9 is 3 to the second power. So what I can use is I can use this to my advantage. So 27, 6 minus t is really the same thing as saying 3 to the third, because remember we said 3 to the third is equal to 27. And that with 6 minus t as its exponents. We can also say that 9t minus 1 is the same as 3 squared, because we said 9 is equal to 3 squared, t minus 1 power. Now what I'm thinking of doing is that, remember when we have two exponents, an exponent raised to another exponent, that tells us we have to multiply. So we do 3, then we do 6 times 3 is 18 minus 3t, because 3 times negative t. Now here we have 3 to the second, and that is all to the t minus 1 power. So 2 times t is 2t, and then 2 times negative 1 is negative 2. So now what we're saying is that, well, we first started by saying 27 6 minus t is equal to 9 to the t minus 1. And now what we have is 3 to 18 minus 3t is equal to 3 2t minus 2. And that sounds confusing at first until you think about this. In order for these two numbers to be equivalent to each other, that means that the exponents have to be equal to each other. Like for example, 3 to the second is obviously equal to 3 to the second. 3 to the third is equal to 3 to the third. So here, 18 minus 3t must be equal to 2t minus 2. And when I solve this like any other algebraic equation, just like any other, I will get that t is equal to 4. So choice 4 is our answer. Next here what we have is the following question. Which expression is equivalent to x minus 4 squared minus 5x minus 4 plus 6? So what I notice now is that this kind of follows the following format. Let's say if y was equal to x minus 4, just a separate equation, I can substitute y into this equation, and it would be y squared minus 5y plus 6. Now, all of a sudden, well, for example, we can see that the choices here are all factored out. So if I were to try to factor this out, it's a lot easier than to factor whatever I have here. So let's first factor out y squared minus 5y plus 6. So I think of two numbers that add to negative 5 and multiply to 6. And those are negative 3 and negative 2. So I can write them as y minus 3 times y minus 2. And now what I'm going to do is, remember, y is equal to x minus 4, so I'm going to sub in x minus 4 to the equation. Now if I keep solving, I get x minus 7 times x minus 6, and that matches answer choice 4. The last question I want to do is not actually any of these over here, because I think these are fairly straightforward. What I want to do here is question number 6. The reason why I want to do this is because it involves imaginary numbers, which we have not gone over too much in this channel. So we're asked to find the solutions of this quadratic, and immediately the easiest way to me would be to use the quadratic formula. To review that, let's just write that out. Let's solve. So negative b, that's 4 plus or minus 16 minus 4, 3, 2 over 2 times 3. Now remember, what determines if this is going to be imaginary or not is if we have whatever number is inside the square root over here, this here, if this is a negative number, that means that we have imaginary numbers because we can't find the square root to a negative number without introducing these imaginary numbers. Let's evaluate. So just in there, we have 16 minus 4 times 3 times 2. That's equal to 16 minus 24. That's equal to square root of negative 8, which we do not know. What we do know is that this can be broken down into the square root of 8 times the square root of negative 1. That is a property that you just have to know about square roots. And this I can actually solve. So rad 8 simplifies to 2 rad 2. And the square root of negative 1 is, well, I. So what we're really working with in this problem is 4 plus or minus 2i rad 2. Or if that doesn't really please you, actually we can do that later. Let's put this over 6. And now what we can do is, because we see here we have the numbers separated in a way, the plus or minus separates them. So we'll divide. So 4 over 6 plus or minus, we have what we have over here. So 2i rad 2 over 6. I'm not sure if the I really belongs there. It looks kind of odd, but let's just go with it for now. So 4 over 6 plus or minus 2, 6, rad 2 times I. Let's put it like that. And we can simplify this a bit further. I'm going to move my work over here so we don't squeeze it on one corner. That'd be equal to 2 over 3 plus or minus. That's 1 over 3, so rad 2 over 3i. And this, my friends, matches with answer choice 1. And there you have it. So you will see a lot of Algebra 2 is about noticing patterns. So, for example, in question 1, we saw that the pattern we need to notice is that 27 and 9 were related, and we can use exponents to solve. That relation helps you solve the problem a lot faster. In this problem, we have to notice that we're really working with a quadratic that is factorable. We just have to do some substitution. If you know that you can substitute any variable, a, b, c, d, e, whatever you want. If you can substitute that variable for x minus 4, we're able to factor this problem out a lot more easily. Last but not least, as we saw with question 6, when you see that if the discriminant here is negative, then we know that it is an imaginary solution, and we'll have an I like answer choice 1 and 4 have. Well, that's it for today. Thank you all for watching, and I will see you next time. Bye.